So in milk, there are so many fat particles present in the milk. That fat particle, like the butter that we take out from the milk, that is basically fat present in the milk. Now, a good amount of fat is present in the milk. So they are kind of suspended in it. They are kind of suspended in the milk, and manually we can't separate them. These fat molecules present in the milk, manually you can't separate them. So thereby you will spin it at a very high speed. So when we spin it at a very high speed, suppose that here you have taken the sample of milk, for example, right? So when you spin it at a very high speed, thereby what will happen? The the fat particles in it, it will spin and it will settle at the bottom. This will settle at the bottom of the container or this test tube here.
Sir,
That is the, yes.
If they're using that for to settle down the fat, we could have also used for the sedimentation also, right?
No, for see, in the case of sedimentation, what happens? The solid impurities, in the case of, for example, you have a mud water or dirty water, the sand particles or soil particles in the muddy water, it is heavier. It is heavy, so it will settle at the bottom. So it is not kind of suspended. Suspended is something that remains in the medium. It does not settle at the bottom. But in the case of milk, the fat particles are kind of suspended in it. Okay, na? It is suspended in it. It will not settle at the bottom. It is not very heavy particles. Okay, it is not very heavy. So thereby, on its own, it will not, via sedimentation, it will not settle at the bottom. So thereby, we have to use centrifugation. So centrifugation is done for milk also via some simple tools. Also, with the help of simple tools, it can be done, right? So first of all, what the people would be doing, first of all, they would be heating the milk about up to 40 degrees Celsius. Before putting this into this pot, it will be heated up to 40 degrees Celsius, right? And we know that milk is a mixture of fat, water, and other things also. Milk contains fat, water, protein, etc. So when milk is rotated inside this at high speed, thereby it kind of creates an external force. Have you guys ever kind of on a like a, what do we call that? Have you guys played on a spinning wheel?
Yes, sir. Yes, sir.
Yeah. So when you sit on a spinning wheel, like, do you feel like an outward force is acting on your body?
Yes, sir.
Yeah. Yeah. You feel like you are being pulled outward.
Yeah.
Getting what I'm trying to say?
Yes, sir. Yes, sir.
Right now. So, or for example, if I were to take a piece of a small stone or ball and tie it to a thread, and I were to spun it like this, I were to tie a piece of a stone using a thread, and if I were to spin it like this, so it feels like the stone is trying to fall away. It feels like it is trying to fall away from my hand, fall in the outward direction.
Yes, sir.
Getting it now?
Yeah.
So it is said to be experiencing a centrifugal force. Right now, it seems to be experiencing a centrifugal force where the heavier particles tends to move away. It tends to move away, like the spinning of a rock, or when you play on a spinning wheel, when you stand on a spinning wheel. Getting it now? Furthermore,
Yes.
talking about the milk fat, the fat present in the milk, it is less denser than the milk. So thereby, in this, generally what we see that it will not be settling at the bottom, but generally it is observed that it will accumulate on the top of the milk. That's what we get to observe. The milk fat being lighter in density, it will settle at the surface of settle at the top of the milk, and it accumulates over there and will form a layer of cream. Getting it now? So many times you would also have observed this, that when you store milk for some time at your home also, sometimes you will observe that a layer of cream will develop on the milk. In whatever container you will be keeping the milk, a layer of fat will develop above the milk.
Like
So
sir,
what?
when like we like boil the milk or anything, like once you like leave it to cool, there'll be like a layer that will be formed on top.
Exactly. And why it forms on top? Because the milk fat is lighter than the milk. The fat present in the milk, it is lighter than the milk. That is why it will accumulate on the top. We know that lighter thing tends to move upward. The things that are lighter, it tends to move upward. So thereby the milk fat will accumulate on the top. So that is what happens over here, right now. So that is the whole principle of the centrifugation done for separation of milk. Here also, as this woman would be churning the milk right now via this paddle, as this is being rotated, the fat inside this will accumulate on the top. It will accumulate on the top, and later it will be separated manually. So hope you guys have understood this procedure.
Yeah.
Nowadays, this is being done using the help of machines also, as you can see in this image right now. So that is the actual churning of milk done via a machine. Got this now? Ira is not here, right? So as it will be spent, so thereby
So
the
like
fat
also when you like have to like make like when people make cakes, they like to make the cream, they whip the milk up to like make it form like a cream like thing.
exactly. Or for example, many times like you have to make coffee, so you'd be kind of doing the same thing there also, right now. So you'd be centrifuging the coffee also. So thereby, what will happen? The buttery substance, right now, the thick layer on the thick creamy substance will settle on top. It will accumulate on top. Got this now? So that is the thing. Hope you guys have understood the procedure so far. Okay.
Sir, sir, could you repeat it because my internet was not working, so I like it accidentally left and I wasn't there.
Okay. Okay. No worries. No worries. See, we were learning about the same thing, about the centrifugation of milk. So we know about centrifugation that it's the process of separating the particles using centrifugal force. Centrifugal force is like, just like when you spin a stone tied to a thread, so the stone will experience an outward force. It will feel like if it is being pulled in the outward direction. Or when you sit on a spinning wheel, right now when you play on that spinning wheel, when you stand on it, I mean to say, you experience an outward pull, like someone is pulling you in an outward direction. Huh? Like there's a, like this one, I think it is, getting it what I'm trying to say. So this is a spinning wheel. So if you happen to play on this, and if you were to sit on this, so when this is being rotated now, so you will feel like you are being pulled in the outward direction. Getting it what I'm trying to say?
Yes,
You
sir.
will feel like you are being pulled in an outward direction. Or do you guys ever experience this, like when you are going through a car, and when your car takes a sudden turn, you feel like you are being pulled in the outward direction, like someone is pulling you in the outward direction. Huh? When your car
Yes.
takes a sudden turn in the road, so it's that kind of thing. So in the case of spinning, the particles present in the liquid will be experiencing an outward force that is called a centrifugal force, right? So here the mixture is being rotated at a very high speed right now. So in this, what will happen? The lighter particles would settle at the top, and the lighter particles will, I mean to say, the denser particles would settle at the bottom, and lighter particles would go up and accumulate at the top. And this can either be done using a simple traditional tool like this, or or nowadays it is being done at a bigger level. It is being done using this machine, a centrifuging machine. Getting it, guys? So that is the thing. Or this centrifugation, it is used in dairies to separate cream from milk. Also, as Halima said, that it is used in the labs for blood and urine test. There also it is used. Also, you guys tell me, what about the washing machines? Does it also not work on the same principle of centrifugation?
Yes, sir.
Right now?
Yes, sir.
So this same principle of centrifugation is used in washing machines to squeeze out the water from the clothes. Getting it now? So that is the thing about centrifugation. Hope you guys have understood this. So if there's any question in it, please let me know. So what are the uses, Halima, we have learned, and Ira, Hana, used in?
So it's used in washing machine and used in
Hmm.
Sir, to make cream, to make
to make
butter.
Hmm.
Sir, even it is made, even it is used for the blood
Yeah.
in the lab. Make whipped cream.
Hmm. Exactly. To obtain cream from milk there. That is the most common use. And then as you guys told,
Sir, butter.
that
To make butter.
exactly used in washing machines to squeeze out water from clothes. To squeeze out water. Water is lighter as compared to the cloth. Now water is lighter, so it will be squeezed. So to squeeze out water from clothes. And the last one, as you guys know, used in labs. Used in labs for blood and urine test.
Yes, sir.
Blood and urine
Sir,
test.
should we write this down?
No, not right now. I will be sharing the PDF as I told you guys. I wanted you guys to show an image. So have a look at this one. Yeah. You guys see this image over here? This one?
Yes, sir.
Right now? So what happens now? The blood sample. Suppose we have to check the number of red blood cells or white blood cells. How many red blood cells are there in the blood? How many white blood cells are there in the blood? So how it is done? So first of all, the blood, we know it's red in color. No, the blood originally it is red in color. So then why here it is yellow in color, light yellow in color? Huh? So the
Sir,
thing is
maybe
that
because of the blood cells.
no. This blood sample was put in a centrifugation machine. And when it was spun at high speed, so thereby the plasma found in the blood, which is basically made up of water, 95% made up of water. So it is lighter in density. So thereby it's accumulated at the top. Okay, na? And other things were denser, more heavier. So it's settled at the bottom. Okay. So there now we have the different components of the blood have been separated and it would be easier to study them. Like all the red blood cells and white blood cells and other things have settled at the bottom. So it would be easier to study this small sample. Like this sample will be studied. Okay, na? And the rest is mostly made up of water. The one that is accumulated over this red liquid, that is water present in the blood. Getting it now? So that
Yes,
is
sir.
how in the blood test the centrifugation will be used. Okay.
Yes, sir.
So we did learn about centrifugation. There's one more thing we have to learn. We have to learn about crystallization also. Isn't it, Halima? So that also has to be learned.
Yes,
So
sir.
let us learn about that also. Okay. So what have you learned about this, Halima? Like how crystallization is used in separation of substances?
What, sir?
How crystallization is used. You have learned about this?
Yes, sir.
So what happens in the case of crystallization?
Sir, in crystallization, um,
Mhm. Basically, we would be obtaining a pure substance from a mixture from an impure sample. Like you have
sir,
to obtain a pure solid substance from an impure
sir,
mixture. Mhm.
it is the process which we separate a pure solid in the form of its crystals from a saturated solution.
Very good, very good, very good, Halima. So crystallization is a process where we obtain the crystals of pure solids from a given mixture, right? Getting this now. So you guys see crystals in everyday life. We have different examples of crystals. Like sugar is a crystal, isn't it? Sugar is a crystal. Different gemstones like emerald, ruby,
So diamond.
diamond.
Fire.
Exactly. Yeah. So all those are also crystals. So those crystals are formed by the natural process. That's a different thing. That took about millions of years for formation of diamond and other crystals. That has happened via natural methods, right? Okay. Another thing is that talking about the crystallization, as Halima said here, that it is obtained from a concentrated mixture of impure substances. So you guys know about how sugar crystals are obtained. First of all, we know that the sugar cane, the juice of sugar cane is extracted. Sugar cane juice is extracted first of all, right now. It would be crushed and juice would be extracted from the sugar cane. Later on, that juice would be boiled. It would be
So what is it
boiled.
obtained from?
Yeah,
What is it obtained from?
sugar cane. Sugar cane is a plant, no?
Yeah, no, you said the crystallization, the definition, like it is
Okay.
obtained from.
Yeah, yeah. I say that it is obtained from a saturated solution of an impure substance.
Oh,
Okay, now.
perfect.
So we have a sugarcane juice. Okay, we would boil it to make it more concentrated. Okay, na? To make it thicker, it would be boiled. Okay. Once it has been boiled, it would be left to cool slowly. It will not be put in refrigerators or in a deep freezer. It would be naturally allowed to cool down, right? So as it would be naturally allowed to cool down, the sugarcane juice will then turn into the crystals of sugar. It will turn into the crystals of sugar. Getting it? Huh? In that manner, how sugar is obtained. Getting it, guys?
Yes,
Yes,
sir.
sir.
Okay. Now, talking about this crystallization process, how it is used for separation, one example we had. Okay, now. Furthermore, we can have some other examples also. Like crystals of copper sulfate are also obtained from an impure solution of copper sulfate. Getting it? Like crystals of copper sulfate, just have a look at this image first of all. You guys look at these crystals. Also, crystals have got a very distinct shape. They have a very special shape. Right now, a sharp and clear shape like this one.
And they don't have a fixed shape. It will be like it'll be like a different shape.
Different shapes, but it will have very sharp edges.
Yeah.
The edges will be very sharp. Okay, now as you can look over here, these are the copper sulfate crystals right now. So copper sulfate crystals will also be obtained, also be obtained from an impure mixture. Via the process of crystallization, it can be obtained. Okay, so talking about how it is used as a separation technique. So here we would be obtaining a solid substance from a impure liquid mixture. From an impure liquid mixture. Got this
Yes.
now? So this process is used to obtain the pure solid substance from the impure saturated solution. So that is how it is done. Okay, now we guys can also perform some crystallization at home if we were to have some falling setup right now. Say for example, you want to obtain the crystals of copper sulfate, let's say. Okay, we want to obtain the crystals of copper sulfate or any other thing. So what we can do, first of all, in the first step, in a beaker.
Sir.
Yes.
Sir, at home I have this like science experiment kit, and in there it comes with crystal powder, and it allows, and whenever you put it in water, it just comes like it absorbs it and becomes crystal.
Yeah, it will take some time and it will then later on convert into crystals. Right now. So first of all, you have to like kind of heat it a little bit. Right now. First of all, it has to be a little bit heated.
Yes, sir.
So I was explaining about the procedure of crystallization, how we can done. So first of all, what you're going to do now, take a solution of copper sulfate. Copper sulfate solution. Okay. Copper sulfate comes in the form of powder also. So you can buy the powder of copper sulfate, mix that in water, and it will give you a blue solution, blue colored liquid like this one. Okay, no, that gives you a blue colored liquid like this one. So you have obtained a mixture of it by adding some water into it. Okay. So once you have boiled it, after boiling it, allow it to cool down. Allow it to cool down. So as it will cool down, so you will observe in this that crystals of copper would have formed. Crystals of copper sulfate would have formed in this. Getting it? No? So in that manner, crystallization can be done at home also. It can be done at home also. Got this now. So hope you guys are able to understand what we are discussing over here.
Yes, sir. Yes, sir.
Okay. So let us quickly sum it up the process of crystallization. It's a process in which the here we have boiled it now, so we can say that it's a process in which the hot concentrated solution of a substance would be cooled to obtain crystals of the pure substance. What I say that it's a process in which the hot concentrated solution of a substance is cooled down to obtain crystals from it. Getting it, guys?
Yes, sir.
Okay, now. Also, crystals, as we know that these are solid particles which have definite shape and sizes, and they are lustrous also. They have a shiny appearance, isn't it? All the crystals that you see, whether it be emerald, ruby, or diamond, all of them they are lustrous. Got this. Also, even if you were to look close enough to a sugar cube, you look close enough to a sugar cube and hold it near a light bulb, that will also be very lustrous if you look closely. Getting it what I'm trying to say? Okay. Also, there are different applications of crystallization. Like one of the application of crystallization is separation of salt from seawater also. You know, like in the process of obtaining salt from the seawater, there also evaporation and crystallization, both of them is happening. First of all, this concentrated mixture of the salt water, it will be hot. It becomes hot in the sun, right now. So that will be allowed to cool down. And then at the end, you will be having crystals of salt like this. So one application of crystallization is separation of salt from seawater also. Another example I gave you of this one, separation of copper sulfate from the impure sample. You have this copper sulfate solution which is impure. Once you boiled it and cooled it, allowed it to cool down, so you had this sample of pure copper sulfate. That is copper sulfate. That is another application of crystallization. Furthermore, you can obtain crystals of alum from an impure some sample also. There is a substance called as alum, AlQm. You guys might have seen it, but alum have got different uses also. You guys have heard of this term before, alum? Alum or potassium? No?
No, sir. No, sir.
Okay. Anyways, by the way, it has got various uses, like it is used in medicines also, used in baking powder also, or basically it is used in pickling also. In making pickles also it is used. Anyways, so uses of crystallization, so far I did told you there are some common uses of crystallization, like to obtain salt from the seawater, or to obtain sugar from the sugarcane juice, or to obtain crystals of copper sulfate from an impure solution. So you'd be having a liquid impure solution. From that, you'd be getting a solid pure crystal. Got this? If there is any confusion in this, please let me know.
So you just give me 1 minute.
Okay. After this, we'll be doing questions on separation of substances. We'll be doing questions on this chapter. Okay, now? Okay, hope my screen is properly visible. So
Yes,
the
sir.
given questions that you see over here, let me zoom it out. So the first question is that, how will you test given solution is saturated or not? Let me just take my charger. Just 1 minute. You guys read the first question.
Sir, then do we have to like answer it in the chat?
Yeah. So what's the answer of the first question, guys?
Sir, do we have to answer it in the chat?
Yeah, you, since all of you would be doing this now, so answer in the chat box.
Okay, sir. Okay, sir.
You guys know where you have to answer. You have to answer on this ID.
Sir, the same with all the other questions?
Yeah, you have to answer the other questions also. Yeah, Ira, your answer is correct.
Okay, sir.
Yeah, what about others? Hana and Halima.
Sir, I'm answering the second question.
Okay. Yeah, Hana. For the first one you have answered, no? That is correct. Good. Yeah, Ira. For the second one, it is correct. Good.
Thank you, sir.
The third question, you have a mixture of paper and sand. How will you separate that? How will you separate the mixture of sand and paper?
Sir, after they're dissolved?
Yeah. After they are dissolved, that mixture can be separated using which method? Miss Hannah, for the second one you have answered. Hannah, have you answered this option for the second question? It is not correct, by the way. Halima, you haven't answered any question yet. Are you going to answer all of them at once? Okay, let me just clear the answer for the first two questions. So how will you test given solution is saturated or not? Right now. So if it will dissolve more solute, if it is able to dissolve more solute in it, thereby it means that at that time it is not concentrated. So when you add more solid, if it dissolves, then it means that it is unsaturated. Getting it now?
Yes, sir.
Sir, so the first answer is the answer of third one, right?
Yeah, that is option
I
number C.
answered the third one.
You have answered the third one. Yeah, good, Ira, that is correct. Very good.
I have also answered the third one.
No, that is correct.
Sir,
Very good.
the second one.
Yeah, second one, what you were saying, Halima?
Sir, the second one's answer
Yeah.
is magnetic separation.
Yeah. But those
So
all
can
of
you
you have
answer the
answered.
third one?
Yeah, 1 minute, just 1 minute. Let me clear the second one. So iron being magnetic in nature and copper is not magnetic. So iron will be attracted towards a magnet, hence magnetic separation will be done. Okay, now for the third,
Copper is magnetic.
yeah, copper is non-magnetic. Iron is magnetic.
So
Getting
for
it now?
the third one, a mixture of pepper and sand can be dissolved in water. The mixture can be separated by the method of filtration.
Exactly. Right now. So a mixture of pepper and sand can be dissolved in water. The mixture can be separated by the method of filtration. Getting it now?
Sir, for the fourth question, the D1, what is a camphor and the
Okay, that is NaCl. That is the common salt that we use at home. Okay, no salt.
sir, what is camphor?
Camphor. Camphor, you guys haven't know about this one. Okay, I will show an image of it to get you to give you a better clarity. See, basically, camphor is something that will not evaporate after some time. Okay, no. It has a property that if left in open, that camphor will evaporate if left in open. Right now, so it starts to evaporate. Getting it? What I'm trying to say? Like camphor, it's a solid substance. So without converting into liquid, it will directly convert into gas, meaning that it will go through sublimation. Sublimation is a process in which a solid, without converting into liquid, will directly convert into the gas. So camphor will directly evaporate, or basically we say that it will go through sublimation. So evaporation will be used to separate which one? Salt from water, pepper and sand, sand and water, or camphor and salt. By the way, camphor has got multiple uses. Like it is used to treat acne, or it is used for curing cough or for pain, if people have itchings on their body. So for that purposes, camphor is used. It would be better if I were to show you an image of it, because we tend to have a better image if you get to see images of things. Yeah, this one over here. I'm talking about this one. See, this is camphor. Getting it, guys?
The shape of
Camphor
a
is
sugar cube.
not shape of a sugar cube, but rather than that, would look like this. Sugar cube is sugar is having a cubical shape. It is of sugar crystals are of cubical shape, but here it does not have a cubical shape. Okay, now it has a rounded shape.
Yes, sir.
And
Sir,
important
like
thing about
camphor, it dissolves on itself, or do you need to put any water or something?
no, the camphor will not dissolve directly into water. It will simply evaporate. Will do sublimation. It will convert into gas. Okay.
Okay.
So what answers you guys have given for the third one? So you are answering B. I don't know. The third one, how can it be B? Okay, sorry, for the fourth one you guys have to answer. No, you have an answer for the fourth one. See what? Let me explain this one. Evaporation is used to separate which one of the two? Which one of these? Salt from water. Of course, we know about this one. Why evaporation? Salt can be separated from the water. Water will evaporate and salt will be left. Paper and sand, no. For
Sir,
that filtration
actually, I
used.
was just typing the answer. I was just going to submit it. I was just typing the
Okay.
answer.
Okay, no worries. Sand and water. Here sedimentation will be used now. Getting it. Sedimentation is used. And in the D1, sublimation is used now, not evaporation. Sublimation and evaporation is different thing, right now. In evaporation, a liquid changes to the gaseous state. That is what happens in the case of evaporation. But in the case of sublimation, a solid is changing directly into the gaseous state. So when you have a mixture of salt and this camphor, so the camphor will go through sublimation, it will convert into the gaseous state and you will be left with salt.
Yes, sir.
So thereby option A is the appropriate one, most appropriate. So hope that is clear. Now there was one more topic left to be discussed in this, that is paper chromatography. Okay, now there are different uses of this, so we should be learning, right? So paper chromatography, it's a technique that would be used. Paper chromatography, it's a technique used to separate mixture of soluble substances in a solvent. Okay, now
Sir,
separate
like
mixture
ink?
like ink. Very good. Like ink.
Like, sir, whenever we print something out and then like if we spill water on it accidentally, then the color, it will all like, blend together.
Mhm.
So, for
Exactly.
example, you can also do it with a piece of flour. You can just crush it and then we
Exactly.
can
Sir, and then like the text, it will become like kind of a grayish purple color.
Yeah, kind of color would be dispersing. It would be spreading into the paper, right now. So paper chromatography, it's a technique used to separate mixture of soluble substances in a given solvent in a given liquid. So say for example, how we can do, we can take a paper, as we have taken a paper over here, and it has been partially dipped into the water, not fully, but partially dipped into the water, right? And as it is being dipped into the water, we will observe that the spots of different colors would be appearing on the paper. Like for the middle one here, you have seen that particularly two different spots are visible here. The red one and the orange one and the yellow color is visible here. So what happens?
Yes.
As the paper would be absorbing the water, so as the water will be absorbed into the paper, so thereby the soluble mixture into this into the substance, the soluble substance present in this soluble substance present over here is the ink. So ink is soluble in water. Getting it? Ink is soluble in water. So as the water will be absorbed by the soluble substance, it will change into different colors, right? So as the solvent would be traveling up in the paper, it takes the soluble substance with it. And different substances will have different solubilities in a given um, mm, in a given solvent. For example, in water, right now. Furthermore, this method will be particularly done to obtain the green pigment, that is chlorophyll, from the leaf. Like you can have a extract of a leaf, and thereby you can obtain the chlorophyll from that. Getting it now?
They're like putting it in water.
Not putting it in water, like you can just take an extract of a green leaf. For example, just take a green leaf, grind it in a mixture. Okay, now then take a very small, take just a small paste of it, a drop of it, put it into a paper, and dip that paper into the water, and thereby you will see that the color of the chlorophyll would be dispersing into the paper. It will spread into the paper. Getting it?
Yes, sir.
Okay, no. So the thing about the paper chromatography is that here we get to see that the soluble substance present in a solvent, it would be dispersing into different colors since it is soluble in water, right? So hope you guys are able to understand this. Okay.
Yes, sir.
Yes, sir.
So here also, what are we separating in this? We are basically separating the colors of the given substance right now. It is used to separate the colors of the given substance. So hope you guys have understood this.
Yes, sir, I understood.
All right. So I'm going to ask some questions to you guys. Then we would be continuing further. Okay. So in the case of paper chromatography, do tell me that here the mixture which we having, do we have solid mixtures? Like the components of the mixture, are they solid or are they liquid?
Sir, could you repeat the question?
The components of this mixture, are they solid? Are they both solid or are they both liquid?
Sir, they are both
They are both liquid now? Exactly. They are both liquid. Okay. Furthermore, what would be the uses of paper chromatography?
Sir, to get the chlorophyll from the leaves.
To get the chlorophyll
leaf
from the, okay, there it would be used. And apart from that, it would be done in many other areas. For example,
it helps to separate colors of a substance.
separate colors of a substance, or in order to check for the water purity, it will be done.
Yeah.
Or to check the amount of drug level in something, it would be used. Getting it, no? Or
Yes.
this paper chromatography can be used to determine the nutritional value of the food item also.
Sir, sometimes people also check their breath with it.
No, that's a different thing. That's a different tool. Okay, no? Getting it, no? That's a different thing, by the way. So it has various uses. It will be used to check the water purity, to check the amount of drug level in something, or to determine the type of chlorophyll present in the given organism, or how much of chlorophyll is present in the given sample. Right now, for example, you were to have a green leaf and you want to check how much of chlorophyll is present in that given sample of the green leaf. Okay, no? So that can also be done using this paper chromatography. Hope you guys are getting it. Okay, no? Okay, so that's all about it. So right now we would be doing some questions. Okay, so let us do some questions then. So the first question which I'm going to ask you, you guys tell me that the process of conversion of water into vapor is called as?
Evaporation.
Sir, evaporation.
Okay. Do tell me what is the principle of separation used in filtration? What is the basis of separation of filtration? On what basis that is based? Getting what I'm trying to say?
So like filtration is like separating like the like example when you're separating impure water from pure water, like
No, I'm saying that different methods of separation which we have learned, all of them work on different principles. Like for example, sieving is based on the difference in size of particles, right?
yes.
Or like for example, winnowing is based on the fact that different particles are they have difference in their weights and difference in their density, like that. So talking about filtration, so there also what do we observe that It is also based on the size of the
It
particles.
seems to like separate the like heavier particles from the lighter particles.
Yeah. So it is also based on the size of the particles of the mixture now. Getting it?
Yep.
Okay.
Yes, sir.
Okay. So do tell me what technique would be used to purify the dirty water? Will it be centrifugation, evaporation, sedimentation, or decantation? To purify the dirty water.
Sir, could you
Or-
repeat the options?
Yeah, I'm repeating the options. Will you be using centrifugation to clean the dirty water? Will you be using the sedimentation or decantation, or will you be using evaporation? What will you be using to clean the dirty water?
Sir, sedimentation.
Yes, sir,
Sedimentation.
sedimentation.
Very good. Okay, now do tell me that I am providing you with a mixture of, you have been provided with a mixture of sand. Let us take salt. Okay, now. So you are being provided with a mixture of salt. Let us take sand also. Salt, sand, then oil also, and water. So what are the components present in the mixture? Sand, salt, oil, and
water.
Water.
Okay. Now I'm going to write some options. You have to tell me which of these sequence can be used to separate salt from it. Okay, now can be used to separate the salt out of it. So the options are as follows. First of all, you would be doing decantation, and then you would be doing filtration. After this, you would be doing evaporation. Okay. Option B says that first of all, you would be doing filtration, then evaporation, and at the end you would be doing condensation. Okay. Or third option says that first of all you will be doing filtration, then you would be boiling it, and at the end you would be doing a decantation. You guys understand what is the sequence of steps you are going to follow to separate salt? We have to separate the salt out of it. Only 3 options I have given. Okay. So just think of the mixture first of all. You have sand, salt, oil, and water. So I'm drawing a beaker over here, a glass beaker. So first of all, you guys answer me which one is heavier in this? Which one is heavy, more heavy, most heavy? Out of sand, salt, oil, and water, which one is heaviest?
Sir, sand.
Sir, sand.
Sand, very good. So sand will be settling at the bottom.
So,
Yes, sir.
filtration will
So
be first.
So for
No, just don't jump to the answer right now. First of all, do this exercise with me. Sand will be settling at the bottom. Okay. After sand, which is more heavier?
Salt.
salt.
Salt, very good. So say that these are salt particles that would be settling above it. After this,
Oil.
Sir, oil.
no, you guys forgot about water.
Water.
Oil is
then
less.
lighter.
Oil is lighter than water. No, good. So after this, you'd be having water, and then finally
Then water. Then
oil on top. Good. Finally, oil will be floating on the top. Okay, so I need to separate the oil. I need to separate the salt from it. I have nothing to do with sand. Okay, no? So you guys tell me that what if I were to separate oil and water from it, then I will be left from sand, left with salt and sand. So first of
Yes,
all, you
sir.
will separate the oil and water. Yeah.
Yes.
Yes. Sir, so
Using Mhm.
decantation.
Exactly. Getting it now. So you will take another container and you will pour the sand and pour the oil and water into this. Getting it, guys?
Yes, sir.
Yes, sir.
So
So then
oil,
you have to
Then
filter,
filtration, then
then you
evaporation.
have to filter it and then evaporate.
exactly, right now. So via decantation, this mixture will be poured into another beaker. Then in this, you'd be left with salt and sand. So via filtration, that could be separated. Getting it? No?
Yes, sir.
So hope you guys have understood this so far. Okay. Via filtration, what will happen? It will be separated, and then finally via evaporations, water will be evaporated and salt will be left in it. That's the sequence we should be following in this one.
Yes, sir.
Okay. So there are